Okay, ladies and gentlemen, let's talk about monomials. Monomials are actually something we use on a regular basis. If I have 4 is a monomial. There's only one part to it. If I had 6 plus 2, that has 2 parts to it. So having 2 parts to it, it's a binomial. If I had 3 parts, 6 plus 2 plus 7, that, shockingly enough, would be a trinomial. Now, we don't normally deal with these as binomials or these as trinomials, because in most cases we can say, well, wait a minute, 6 plus 2. 6 plus 2 I can turn into 8, and if I'd say 6 plus 2 is 8, 8 is now a monomial. Or I take 6 times 2, or 6 plus 2, that's 8 plus 7, that's now a binomial. But if I take 8 plus 7, I can make that 15, that's now a monomial. So, mono meaning 1, bi meaning 2, tri meaning 3. Mono, bi, tri. It should match up with some of the other words that you're familiar with. Okay, a tricycle, 3 wheels, a bicycle, has 2 wheels. A monopod would be something that only has 1 foot. Okay, so those are monomials. Now, we can, on a regular basis, take 2 monomials and multiply them. We're used to that. That's a monomial, that's a monomial. You multiply them, you get 16. That's also now a monomial. You'll notice this is a binomial because it's separated by a plus or minus. Trinomial separates plus or minus, so term 1, term 2. They're separated by plus or minuses. Now, we're not really going to get too much into that today, but you need to know the words so that when we get to the book, it makes more sense on what you're up to. Now, if I take a monomial 4 and a monomial, you notice it's not a binomial because it's separated by multiply, not plus. We have 4 times 4 is 16. That's no big deal. But what if I have x times x? Well, x times x I can't turn into a single number like I can 4 times 4 turns into 16. But I can say x times x is x squared. And now I've taken something that was 2 different monomials and combined them into just one. There's no plus or minus sign involved here. Now, if I were to have something like x plus 2, that's a binomial because it's separated into 2 pieces. And let's say I want to add it to 3x plus 7, that's a binomial because it's separated into 2 pieces. I would combine the like pieces. What's x plus 3x? Well, that's 4 x's because I had 3 x's here, I have 1 x here, I put them together, I have 4x. Now here I have 7 plus 2 is 9. 4x plus 9 is the total answer. Now, this is now from 2 binomials, I've made 1 binomial. You'll notice I can't put this into one piece because do x's go with regular numbers? No, you have to combine like terms. I can take x's here and put them together. I can take number and number and put them together by addition, but I can't just combine 4x and 9 because they're not the like things. That's like saying 1 orange plus 3 oranges is 4 oranges, and 2 apples plus 7 apples is 9 apples. If I have 4 oranges and 9 apples, I certainly don't have 13 or apples. That doesn't make any sense. So you have a binomial. So that's binomial. This is a monomial. Now, all of that is necessary to start talking about the following. If I have x to the third times x to the fourth, we've already talked about doing exponents. How many do I have here? I have 3, I have 4, so now I have x to the seventh. All right, that's a nice monomial. It's put together. If I have 4 squared times 4 to the fifth, well, how many 4s do I have here? 2. How many 4s here? 5. So I have 7 4s altogether. All right. Now, let's get a bit more complicated. What if I have 4 squared x cubed 4 to the third x to the 7th? Well, these are all times, and just like I can say 2 times 3 is 6, and 3 times 2 is 6, I can use the commutative property to switch these around in order. In this case, I can do the same thing. I could say 4 squared times 4 cubed, and so I have that one's here, that one's here. Then I have x cubed, x to the 7th. And I can put them in order. Now, it's just like having this problem and this problem, but we can do them separately. So here I get 4 to the, there's 5 of those guys, x to the, there's 10 of those guys. And I've put them together. Now this is still a monomial because it's separated by times, not by plus or minus. Plus or minus breaks it into 2 pieces. Even though you see 2 different things, they're together because they're smashed right up against each other with a multiplication sign. Okay, so if I have something like the following, let's get crazy here. 4 to the third, x fourth, that's a monomial because it's a time sign. And 4 to the first, x to the 5th. Now, in this case, we're dividing, and anytime we divide bases that have powers, we simply say, how many 4s do I have on top? I have 3. How many do I have on bottom? Well, I have 1. How many x's on top? How many x's on bottom? Now, 4 divided by 4 is 1. So how many 4s do I have left over after I cross one out of the top, one out of the bottom? 4 squared. And then I have x is gone, 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 x is gone. Where's the only thing I have left? 1x in the bottom, or x to the first. So we can reduce there. That is also a monomial. It has 2 pieces, one on top, one on bottom. But remember, just like 1/2 is a fraction 1 piece together, 4 squared over x is also 1 piece together. It's not connected by plus or minus. All right, let's do a hard one. Let's take a look at x cubed, y to the 6th, z to the 9th, all over x, y to the 4th, z cubed. Okay, so with that, we have how many x's on top? 3. How many x's on bottom? 1. If I take 1 out of the top and 1 out of the bottom, I'm left with x squared. Now, for y's, I have 6 on top, 4 on bottom. So if I take 4 out of here and 4 out of here, I'm left with 2 of them. And finally, I have 3 z's on the bottom, 9 z's on the top. That's z to the 6th. And so that's what I'm left with. You say, well, that has 3 pieces. But remember, it's a monomial because trinomials are separated by plus signs. There are no plus signs involved in this problem. All right, I think we can probably take care of it at this point. So let's see how we do when we do a little homework.